Hi, this is Adolph Oliver, and this video is talking about graphing using a table of values. There are going to be three different methods we're going to introduce you to. The table of values is the first one, and it's designed to work with equations like x plus y equals 5, where we have more than one variable and there's an unlimited number of possible solutions, XY combinations that would solve this. So it's impossible to write them all down. What we do instead is we draw a picture, a graph, to see the solutions. Now, if both the variables, the x and the y, occur to the first power, and remember, if you don't see variable or exponents here, then you assume that the exponents are 1, they're to the first power, then that means the graph line we get is going to be a straight line, and that's why these are called linear equations. Well, anyway, let's talk about this table of values. The first thing we're going to do here is we have to take the equation and solve it for y equals. So there's officially a plus in front of the x here, and what I'm going to do now is jump it to the other side. So I end up with y on the left equals, and I've still got the 5 on the right, but this plus x, since we jumped the other side of the equal sign, it's a single term we're jumping, comes over as minus x. Okay, we always want our table of value equations in the form y equals. There are a couple of reasons for this, and we'll show you these as we go along. Well, the next thing is to make up our table of values. So here it is. Okay, I normally make it in what looks like a T-chart here, very similar to what they use in accounting. And I put the x's on the left and the y's over here on the right. Now, the first thing you want to know is that you pick the x values. And you're free to pick any x values you want, but of course, if you make good choices, then the rest of your work is easier, and we'll show you how to make good choices as we go along. Okay, the y then is calculated from the equation, okay, up here, using the x value we chose. Now, my favorite x value is x equals 0 because it's so easy to be able to figure out what the y value is. So let's put that in here. I'm not going to make it my first entry. I'll make it my second here. So x equals 0. Now, if x equals 0, this would be 5 minus 0, so y would just equal 5. And there is our first xy pair that's on our graph line. We'll graph it over here in just a moment. Now, going back to the equation, there's only a plus or minus, I should say, 1 in front of the x here. Remember, if you don't see a number, you can always put a 1. Now, that's not a fraction, so we can pick any x values that we want, and we won't get messy answers. That's the main thing we do here, is try and stay away from messy answers. Now, what I normally do in a case like this is say, okay, let's take x equal to either -1 or -2. I pick one on the negative side and pick one on the positive side because we want to stay right around the origin here, the middle of our graph. So let's say I picked x equals -1, and then what I do is go the same distance the other side here, x equals +1, and there would be my choices. So I always pick x equals 0 and then figure somebody negative and somebody positive. Okay, well, if we put these back in here then, what's y equal? Well, remember, it's 5 minus the x value. I'll make a hole for the x. And in this row, we've got x equal to -1. So the two minuses here give me a plus. So this equals 5 plus 1, which equals 6. So for x equals -1, y equals 6. We already have x equals 0 and y equals 5. Now go down to the last row. Okay, again, write what the equation is. Y equals 5 minus, and here's the x, so I make a hole for it. Now, the plus and minus here combine to a minus. So this equals 5 minus 1, which equals 4. Now we always want to have 3 XY pairs to be able to graft our line. You really only need 2 if you didn't make any mistakes. 2 lines or 2 points will allow us to draw the line. But we humans have been known to make mistakes, so we always add a 3rd point. And then when we plot these, we make sure they plot in a straight line. Well, let's see how we did here. Okay, here we are. X equals -1 would be right here, 1 to the left of the origin. Remember, this is the X going this way and the Y going upstairs. And then we want Y equals 6. 1, 2, 3, 4, 5, 6. So right there, there's my first point. X equals -1 and Y equals 6. The second point, X equals 0. Okay, here's X equals 0. Got to go 5. 1, 2, 3, 4, 5. Okay, right there is the second point, X equals 0 and Y equals 5. The third point has X equals 1 and Y equals 4. 1, 2, 3, 4. There it is right there. Well, there are 3 points. They sure look like they fall on a nice straight line for us. And if I was to draw a line through those, it'd look like this. Now, officially, this line goes forever, both directions. And, you know, we should put arrows to indicate that, but most of the time we don't bother doing it. Folks working with these guys know that they go forever, both directions. Okay, well now, let's move on and look at something else here. Here's another one to work at. Notice that we already have it in Y equals form here, so that's nice. But there's a fraction that's in front of the X. The coefficient for the X has 1/3. Well, here's the key. If you pick X values, which are multiples of 3, then it will make your calculations come out an awful lot better. So let's slide this over and we'll make our T-chart over here and I'll show you how that works. Okay, here we go. Here's the X's again. Remember, you pick the X's and we calculate the Y's. Okay, well, first off, remember my favorite X is X equals 0. I always put that down here in the middle. Now notice why it's nice. If X equals 0, then this 1/3 times X is just 0. Y just equals 4. So it's so easy to get the Y value that we can't pass that up. Now, here's the key. Pick values of your other choices of X that are multiples of 3. I want to be 1 on the negative side, 1 on the positive side, so I'll just go -3 and +3. Now we're going to see real quick why those work out nice. Remember here now, we've got 1/3, okay, times our X plus 4. Well, the X that we had for this row was -3. You turn around and put that in, and notice that the 3's cross cancel. Okay, we end up with 1s in both of those, and we cancel them. Well, that's beautiful, because what we end up with, I'll write it up here where I have a little bit more room. We have on top 1 times 1, which is 1, and the bottom 1 times 1, which is 1. But there's a single minus sign right here, so that means it's -1. And of course, don't forget the plus 4 that was in the equation. So we end up with 3. So for our first point here, X equals -3, Y equals +3. Okay, we also have our second point with X equals 0 and Y equals 4. Now we just go down and do it with the third guy. Again, 1/3 times our X value plus 4. Well, the X value is +3 in this row. Again, the 3's cross cancel here. So I end up with 1/1. I'll write it right here, and there's no minus sign, so officially that's plus. And then we have the plus 4. Okay, well, that equals 5. So plus 3 for x and 5 for y. There are the three pairs that we can use. So here we go. X equals -3. 1, 2, 3. Okay, y equals +3. 1, 2, 3. So there's my first point right there. The second point is x equals 0. Okay, right there. And then I have to go up 4 and y. 1, 2, 3, 4. There's the y value. The last point is x equals +3. Here that is. And y goes up 5. 1, 2, 3, 4, 5. There we go. Now, draw a straight line through those. Okay, here we go. Oops, I missed a little bit, but there it is. If I'd have hit it better there, you can see that this is a straight line. And again, we're good. So here's one of the reasons why we always want to solve the equation for y equals when we're doing a table of values, so we can find good multiples of x to use. If you'd have used different x's, you would have had fractions over here. You could get the correct answer if you didn't make any mistakes, but it's a lot more work. Okay, well, let's look a little bit further here. Okay, here we've got one where notice we have it solved for y equals x again, so that's great. We don't have to do any beginning work. And there's a nice whole number in front of the x here. So that means that we don't have to worry about, specific values of x to pick. Any nice integers will work. What we're just trying to do is keep away from fractions. Okay, so over to the right here, let's again make our table of values. Here it comes, x's and y's. Now remember, you can pick any x's you want as long as you calculate the correct y's. The points you'll get over here will give you exactly the same line. They'll just be in different spots, but you'll get the same line. So again, it's good to pick x's that make life easier for you. Okay, again, my favorite x equals 0. If x equals 0, this term is 0, so y just equals 2. That's just too easy to get that one to pass it up. Now again, we're free here to pick whatever x's we want. So again, if I just went like -1 and +1, then we can calculate pretty easily what the y value is. It's going to be 3 times the x value plus 2. And in this particular row, I've got x equal to -1. So this would be 3 times -1, or -3 plus 2. The y value would be -1. Okay, now we of course got the value for x equals 0 already. That was real easy. Here comes the next one. Down here where we have +1, once again I'll go to the original equation, make a hole for the x, write everything else back down the same, and we got a +1 that we decided to use for this row. So this is +3 here. When we multiply these together, +2 equals 5. So here are the 3 xy pairs. Let's plot them up. X equals -1. Y has to equal -1. So there's my first point right there. X equals 2, or I should say x equals 0. All right, here. Y equals 2. So go up 1, 2. There it is right there. There's my second point. Here comes my third point. X equals 1 and y equals 5. 1, 2, 3, 4, 5. It'd be right there. Well, those look like they all fall in a nice straight line, so let's just go ahead and connect them. So if the points that you get fall in a straight line, and you feel very good that you got these all correct. If, on the other hand, there was a point off to the side, and when you connected them you got a bend, then you know there's at least one thing wrong over here in your table. Be sure that you come back and check everything in the table to see where the error is. Anytime you have one of these xy equations where x and y are both to the first power, you should get a straight line, so make sure that the 3 points that you plot fall on a straight line. Okay, well, Now, here, of course, is a situation where what we're going to have to do is solve that original equation again for y equals. And there are two reasons, of course, we know why. We want to see if there's a fraction in front of the x, so we know good values to pick for x. And also, it makes it easier to solve for y. So here we go. This is officially a plus 2x in front. So I'm going to jump this over to the other side. So what I've got here now is 5y, okay, equals 10 minus 2x. Okay, the 5y stayed in the left, the 10 stayed in the right. The plus 2x, when it jumped the other side, became minus 2x. Okay, now what we do is we divide everybody by 5, so we get the y just by itself. Okay, so here it goes. The 5's, of course, cancel here. So what we end up with, y equals 10 divided by 5 is 2, and then we have minus 2/5 times the x. You can drop the x down behind or keep it upstairs, your choice. Either way works. Well, now, look at what we have. We have a multiple of 5 to use for the x's here, because we had a 5 in the denominator. Okay, and of course that's why we did this, so we could see that. Okay, well, let's make up our t-chart now. Here we go. Once again, we pick the x's, but of course we want to pick x's that make the calculations of the y's easy. Well, let's get our favorite friend first, x equals 0. And if x equals 0, this last term is 0, so y just equals 2. So there that is. Now, since we want to have multiples of 5, I would pick negative 5x and positive 5x. And those would be the two that I'd use. Okay, what are we going to get? Well, 2 minus, see, we're going to plug in here what y equals, minus 2 over 5 times the x value, which for this row we pick negative 5. Here it is. Well, again, you can see why this works well. The 5's cross cancel here, and we don't get a fraction. We got 1 times 1, which is 1 downstairs. Upstairs, I've got negative 2 times negative 1, which is positive 2. So let's see, writing up here where I have a little bit of room left. 2 plus 2, that gives me y equals 4. So for x equals negative 5, y equals 4. We've already got x equals 0 and y equals 2. Now down here we'll do the same thing. 2 minus 2/5. Remember, I'm taking our original equation up here, solve for y equals, and I make a hole for the x. Here it is. I'm going to plug in the x value. Plus 5, since this is a fraction, I'll put a 1 underneath it just to match it up. And so what do we have here? Well, again, the 5's cross cancel. That's why picking these guys as multiples of the denominator works so nicely. So what do we end up with? I got room down below to write it here. 1 times 1, the denominator is 1. The numerator, negative 2 times 1, which is negative 2. So 2 minus 2 is 0. So for plus 5, y equals 0. Okay, well, let's plot these guys up and see exactly what we've got here. Okay, x equals negative 5. 1, 2, 3, 4, 5, right there. Y equals 4. 1, 2, 3, 4. There we are, right there. X equals 0. Y equals 2, right there. X equals positive 5. 1, 2, 3, 4, 5. And then y equals 0. Okay, it's going to be right there in that point. Okay, once again, this would be a little bit easier if you had a ruler here, but I'll kind of fake it here. Here it goes. Looks like we're on a straight line, even though my line is pretty wobbly. You can see that the points do fall on a straight line. So once again, solving it for y equals did two things for us. They allowed us to pick good multiples of x, and then they also made it easier to solve for the y values. Okay, let's look at one last example here. Here we go. And on this example, what we've got is, let's see here, a simple equation. X equals 1. Now, this is something to watch out for. Whenever you end up with an equation to graph, and you're supposed to graph it on an XY plot, and that's what's given here, and one of the variables is missing, then it's real easy to graph. You don't really have to use any of the three methods. You simply say, okay, the one requirement here is x equals 1. Since they don't mention y can be anything. So where's x equals 1? Well, it's right here. But now, of course, since y can vary, what you do is you draw your graph line perpendicular to the axis, the x-axis, where x equals 1, and you just check this. Is it true that every point on this line has x equals 1? Well, every point would be x equals 1 here. And since they don't mention y, they don't care what y is. So, of course, officially, this goes, forever both directions. But whenever you have one of the variables missing, you don't have to use any of our grafting techniques. Just graph the thing right out. There it is.